All right, so now we're back, part two. Let's take a look at the second example here. Quadrilateral RECT is a rectangle. Find x, y, z. So this is similar to the first one, although in this picture, everything that we're looking at, these are all angle measures. Okay, so we're going to be using our angle relationships. Let's start with, well, we only have one number here. We have 26. So let's take a look at this top triangle. Now, one thing we know about rectangles is the diagonals are congruent, so all their parts are congruent. That means the triangle's isosceles. So if these sides are congruent, then the angles opposite the sides are also congruent. So this is 26. That's 26, that's 26. Now to find x, let's go ahead and add those two numbers up. You know that all three have to add up to 180. So 26 plus 26 equals 52. Subtract that from 180 to find whatever's left, and what we get is 128. Okay, so x is 128 degrees, so right away we got x. Nice. Now we need to find, we need y, we need z. I'm going to go for z. Notice that the x and the z, they are adjacent. They have the same vertex and ray right here, and they form a line. A line is 180, so they're supplementary. So if we do 180 minus 128, we get 52, and z equals 52 degrees. Okay, so that's good. So we need one more, we need y. Now y is part of this triangle. There's a lot of ways that you can think about this. But one thing you don't want to forget is that in a rectangle, you know the angles are 90. And so, angle ERT is 90 degrees. This is 26. This piece is 26. So this piece would be 90 minus 26, which is 54. And so what happens here, let's see, so we got 54. Oh, 64, excuse me. I knew that didn't sound right. Okay, so that's going to be 64. This is an isosceles triangle. Okay, let me draw it separately down here. We got that and that. If I draw arrows to the opposite angles, they have to be congruent. So if this is 64, this one's 64, that's the y value, also 64. Okay? So there's our answers for x, y, and z. Now number three is a little bit different. Quadrilateral QRST is a rectangle. Okay, we need to know that. Find the length of QU. QU is here if SR is 86. So SR is this whole thing. That whole thing is 86. Well, what we know about the diagonals is that they're congruent, which means that because they bisect, all the pieces are congruent. So if the whole diagonal is 86, then that means each piece is 43. 86 divided by 2. If these are 43, then the length of QU is also 43. All right, so that's it for number 3. Let's go ahead and flip it onto the back. Take a look at number 4. Let's see, complete a rectangle by adding 2 vertices in the first quadrant. So let's see, they give us 2 points. We need 2 more points, so when we draw this thing, we get a rectangle. Now to do this, you know a rectangle has right angles. Well, right angles, 90 degrees, means we would have perpendicular. Perpendicular means the slopes are opposite, reciprocals. So if we can figure out the slope of one segment, we can figure out the slope of the perpendicular segment. So I'm going to take this -2, 3, and then -1, 0. I'm going to count the slope. So I go down 1, 2, 3. that's negative, and then over 1 to the right is positive, so that slope is negative 3 over 1. So if the slope is negative 3 over 1, then the perpendicular slope is the opposite reciprocal. So I flip the fraction was negative, so now it's positive, it's 1 over 3. So what I can do here is I'm going to take this point, I'm going to count 1 over 3. I'm going to rise 1, run 3. I could put a point there. And then rise 1, run 3, and I'd put a point there. Now here's the thing. If I draw it like this, it's going to give me a square, which is still a rectangle, but let me make it just a rectangle. So I did rise 1, run 3. Let me do it again. Rise 1, run 3. Here's another point. And then here, let's rise 1, run 3. And now when I connect it, there's my rectangle. Okay, so you're using your knowledge of slope and perpendicular lines to solve this problem. All right, the last one here, number 5. What is the length of AC in rectangle ABCD? So AC, this is a diagonal. There are 2 ways you can do this. One way is use distance formula. Square root, you can do the square root x2 minus x1 squared plus y2 minus y1 squared. But I think something that's easier, notice that this is a right triangle because it is a rectangle, so this is 90. We could do a squared plus b squared equals c squared, which is Pythagorean theorem. We haven't talked much about this, but A, B, and C is always your longest side opposite the 90 degrees. The reason why I would do this is because we can figure out this length. Just count it. If I go from A to D, I would go 1, 2, 3, 4, 5. That distance is 5. Now, I did go down, but I don't need to worry about negatives. I'll just keep everything positive. And then the distance from D to C is 1, 2, 3, 4, 5, 6, 7. So my A is 5 squared, plus my B is 7 squared equals C squared. That's 25. 7 times 7 is 49. And the reason why, let's say I put negative 5 here. If I square a negative, it's still a positive. So that's why I didn't worry about negative 5, positive 7, negative 7, anything like that. Add those up, you get 74. Now the way that you solve this, to undo a square, you have to take the square root of both sides. And we'll get a decimal here. Square root of 74 equals 8.60. So we'll say that C equals 8.6. And that is the answer, and that is the end of the notes.